record. Damn it. Sorry about that. Okay. Let's talk about the investment function. Okay. And how we might make this more realistic. I'm sorry for those who are watching this recorded video. I'll go back at the end of class and run through what we missed in the first couple of minutes of class when I forgot to record. God damn it. So the investment function. How could we make this more realistic? Well, quite honestly, we talked before about people being credit rationed. Firms are credit rationed too. Firms are not able to borrow as much as they want. And so just for the same reason, we might think about an investment function in which people cannot borrow as much as they would like. So as a result of that, notice here that now investment is a function of long run output, but it's also a function of short run output.
Can you please share your screen?
Yeah, thank you. Right. So here I've written the investment function, where the first line here is what we had before, where investment is largely a function of long run output and the interest rate. But now we add this additional factor where now short run output also impacts investment. And once again, the idea here is firms are credit constrained, right? So when short run output goes up, it allows them to fund more investment through internal finance. Right? Internal finance. What I mean by internal finance is basically by retained profits, keeping their profits to pay for their investment. And once again, let me just re-emphasize here. Why credit constrained? They are credit constrained because of imperfect information. And the fact that lenders have worse info than buyers and when they have worse info than buyers, lenders are reluctant to lend money, right? So it's this problem of asymmetric information that makes it hard for lenders to lend money because they don't know who's a good credit risk. They don't know which investment projects are going to be very profitable and which aren't. So what that means is that it's, for most firms, they cannot borrow as much investment. They cannot borrow as much to make as much investment as they like. And so what this consumption function, or I'm sorry, what this investment function suggests is that when firms see an increase in their current income, they want to invest more because that current income allows them to internally fund more investment projects that they couldn't get loans for previously. So if you add this to your model, what do you get? Well, once again, I'm not going to work through the algebra. As I said, I give you a question that's somewhat similar to this on the homework that I'm going to ask you to work through. But what you can show is you really get the same thing that we found before. You get a multiplier effect. Because this is greater than 1. So now in this model, if there's a 1% increase in A bar, short run output goes up by 1 over 1 minus XC percent, which is greater than 1. Okay? So you can have multiplier effects in this model pretty easily, right? Add multiplier effects, and this is probably a more realistic way of thinking about macroeconomics, is making the consumption function or the investment function a function of current income, not just long-run income. Let's look at another example of this. How about government purchases? What happens if government policy is written so that the government spends more when short-run output is less than 0? This is what we call automatic stabilizers. These are things like unemployment, poverty assistance, food stamps, Medicaid. Okay. These are just some of the automatic stabilizer programs that we have in the US. And what happens is that when we go into recession and people's incomes fall, more people qualify for benefits from these kind of programs. In other words, what we see is that government spends more when short-run output is negative. We've certainly seen that during COVID, right? In addition to automatic stabilizer programs, there's also basically stimulus policy. Where the government provides many different forms of spending when the economy goes into a short run, goes into a recession. For example, the stimulus checks we just talked about, right? The government decided to give every taxpayer $1,200 when the economy went into a recession in a way to try to stimulate spending. So government spending went up when short-run output goes down. We know that this is true in many different countries. So in other words, maybe with this in mind, how could we think about government spending? Well, once again, there's a permanent level of government spending, like we talked about before. But now, government spending responds to short-run output. And notice that this is negative here. Why? Because when short-run output goes up, the government spends less. And when short-run output goes down, the government spends more on these discretionary policies. What happens if we plug this into the IS model? What do we get? Well, once again, we get a similar result here. Similar, but not the same. Because notice what's happening here. Before, this is 1 over 1 minus x bar. Now it's 1 over 1 plus x bar. In other words, instead of being greater than 1, now this is less than 1. This is no longer a multiplier. It's a stabilizer. That minimizes or reduces the size of the changes in short-run output. So just like we can have multipliers, we can also have stabilizers. So think about how this stabilizer works. The economy goes into recession, short-run output goes down. But when short-run output goes down, the government spends more. And when the government spends more, then it's able, then that pushes up output, okay? It pushes it back up a little bit. So output goes down, but then the increase in government spending pushes output back up, right? Maybe not all the way back up, but at least partially part of the way up. And so depending upon how you write or how you put together your consumption function, your investment function, your government spending, we haven't talked about exports and imports. You could do the same thing where you could make these a function of current income. And if you do that, what you find is that you get a complicated, you get stabilizers and you get multipliers, right? So the way that a demand shock contributes to a change in short-run output becomes more complicated. And that's probably more realistic in the real world, right? In the real world, whenever there's a demand shock, there's probably a complicated series of multipliers and stabilizers that occur, right? There's multipliers from consumption spending, there's multipliers from investment spending, but then there's also stabilizers from fiscal policy, and there's stabilizers from monetary policy, okay? So these are, you know, I think one of the interesting things about the IS model is that you can continue to complicate it in many, many different ways, right? This IS model, you can put all these little complications in and think about them individually. And so, as I said, there's a question on homework number 3 in which I ask you to do this. I ask you, consider the IS model, but with one additional complication, work through it, right? Try to explain what's the intuition behind what you find, okay? So that's that's really it for chapter 11, right? We got through most of chapter 11, I think most of chapter 11 there. So tomorrow, there's one part of this whole thing that we didn't really talk about, which is interest rates, right? We didn't really talk about where interest rates come from. And so that's what we're going to talk about tomorrow when we talk about something called the MP curve, okay? And so that will be chapter 12. That's the next step. The next component of the model is talking about the MP curve. And so that's where we'll pick up at 9 a.m., okay? All right, let's talk about your exam quickly. And I'm just going to I put together a very simple key. This key actually doesn't have answers to many things. I just didn't take the time to write them out, but I will kind of talk about them as opposed to writing them out. So let's just kind of go through this question by question. If I'm going through this too quickly or I'm not being clear, please slow me down. First off, what's the difference between the long run and the short run? Wait. Yeah, sorry, this is the right. Actually, I'm sorry, I rephrased this question a little bit differently on your exam, but it's still basically the same. What's the difference? I changed the question on your exam, but I didn't change it on the key. What's the difference between the long run and the short run? How do economists separate these things empirically? So how we do that is by calculating trend and deviations from trend. So the long run is trend behavior, meaning behavior over long periods of time. And the short run is deviations from trend, meaning actual minus trend. How do we calculate trend? Well, really, we calculate trend based on the behavior of long-run average output. And we usually do it either linearly or exponentially or using a moving average, okay? So the key thing that you had to have here was you had to talk about how the long run is trend behavior, the short run is deviations from trend, right? That's how we define the long run and short run in macroeconomics. Suppose you calculate the average growth rate between year 0 and year t as follows. Is this correct? No, this is just an average growth rate. But what this does not account for is exponential growth and compounding, okay? So just calculating an average growth rate, right? If it's growth over 100 years and dividing by 100, that is ignoring compounding. And so you have to calculate using the implicit constant growth formula we talked about in class, because that incorporates compounding. What do economists mean by chain-weighted GDP? Basically, you calculate real GDP using the previous year, you calculate real GDP using the post year, and then you average the two so that any differences in prices between goods get averaged out. Finally, question number D, letter D. You're a staff economist and your manager asks you to determine which of these 4 countries has the highest standard of living. Fill in the table. So here you're given GDP in millions. How do you calculate per capita GDP? You just divide by the population, which gives you these numbers. And I should have copied and pasted these into your exam. I think if you missed this, I just copied and pasted these numbers into your exam. So this first column is a column up here. Then how do you get per capita GDP in the US? Well, you have to, in this case, you have to divide, right? You have to divide by the exchange rate. right? Because you have to put them in that country's dollars versus US dollars. So if you divide this first column by the exchange rate you're given, you're putting that into US dollars. And then the third column is, now I have to adjust by differences in the price level. So the price level is this column here, PI divided by PUS. I have to divide by the price level to get these columns, these figures in the third column. And so what do you see is, in terms of purchasing power parity, the UAE has purchasing power parity GDP of 18,322, Luxembourg of 129,000, Canada 41,000. The US, because it's all in dollars, and we're all comparing this relative to the US, stays at 54,000, right? So basically you have to divide by the exchange rate and then divide by the price level difference to get the purchasing power parity exchange rate per capita GDP, right? That's a mouthful. So we did this in class, and this is really asking you to do this same example, but for these countries. Okay, for question number 2, here's our solo model. A lot of you set this up right. There were just small math errors here and there. If you set it up right and there was just a math error, I only took 1 point. If there was a small error in conception, then maybe I took a little bit more off than that. But I tried to give you, actually for this one, a lot of credit for doing it or setting it up right, even if you didn't do it right. Let me also say that if you did it wrong, but you could tell that your answer was wrong, then I gave you a lot of partial credit. But if you set it up, or if you did it wrong, and you got a wrong answer, but tried to explain it as a right answer when it was clearly wrong, then I most likely took off more points. So to calculate the steady state, you basically set delta K equal to 0. You should have got here something around the order of 50, right? And then how do you calculate the change in K the next period? You just use your delta K delta K formula. So you plug in here for each of these, noting that now the capital stock is 35. What should you get? You should get 0.99 or something close to 1. That makes sense because it's positive, and it should be positive if your capital stock is below the steady state that you found. Okay, so if you argued, if you got a capital stock that was below the steady state, but you came up with a negative number for this, that was a big mistake, right? If you tried to argue that was right. But a few of you came up with a negative number and said, no, that can't be right. And that was good, right? That was good. And I tried to take off very little points for that, because even if you did it wrong, if you kind of if you understood that you did it wrong, then I didn't want to punish you very much for it. Okay, the next question, constant returns to scale. Constant returns to scale says that if you double all inputs, output should double, right? So if you double both capital and labor, output should double. Yes, this production function exhibits constant returns to scale, and you could show that by either picking numbers or just saying that the coefficients add up to 1, right? The coefficients in this production function add up to 1. How about diminishing marginal returns? Diminishing marginal returns say if you increase one input while holding the other input constant, the marginal product of that input that's increasing goes down, right? So in other words, if we're talking about the diminishing marginal returns to capital, that the marginal product of capital goes down as the level of capital goes up. And yes, this production function exhibits that as well. Part C here, assume you're trying to develop a model that explains the differences in income between rich countries and poor. In which model will you find total factor productivity explaining more of a difference, a static or a dynamic model? As we talked about in class, dynamic models make total factor productivity more important. Why? Because as I wrote right here, in the solo model, an increase in A not only increases output, it also indirectly increases output by incentivizing more investment in K, capital. So in the solo model, when you have an increase in technology, it doesn't just directly increase output, it indirectly increases output by encouraging you to get more capital as well. And so as we talked about in class, that's why the Solow model finds that A and total factor productivity is even more important than in the simple model that was not dynamic. Finally, here for question 2, consider the following figure. Is this consistent with the Solow model? Well, I actually was kind of open to multiple arguments here. I was just looking in some consistency and clarity to your thought. There is one argument that yes, there does appear to be a positive relationship between the savings rate and the level of income. And that is definitely holds in the Solow model, right? Because an increase in S shifts up our steady state and causes us to be richer in the long run. However, I think you could also look at this and say, boy, that relationship is not very close. There's a lot else that's going on here. And so a couple of you argued, no, I don't think this is consistent with Solow because there's too much variability here. And I can see that argument too, right? I can see that argument too. So, you know, I was just kind of interested in seeing how you would address this and whether your argument kind of made internal consistent sense, right? But I guess personally, I would have argued that, yes, this is somewhat supportive of Solow, but the fact that there's so much variability here, I think also raises some questions about Solow. And I think why is there so much variability? Part of it is because this doesn't capture changes in institutions, which we've talked about a lot. And institutions are just as important as savings rates when it comes to why some countries are rich and other countries are poor. Question number 3, our Romer model. Why are ideas scalable in ways that most goods are not? Well, this has to do with the fact that ideas are intangible. And as a result, they create leaks and matches. How does this explain the cost structure of ideas? Ideas also have very large fixed costs, which means that they have declining average cost. And falling average cost means that there's going to be economies of scale. The more you produce, the cheaper it is. And that also contributes to the scalability of ideas. So, you know, I was really looking for 2 things here. You talk about the nature of intangible ideas, but also talk about the cost structure of ideas and how ideas have falling average cost, and that also encourages them to be scalable. Here's our Romer model. How's this different? The only way that it's different is that we have this 2/3 here on A. What does this mean? We have diminishing marginal returns to ideas, right? When there is an increase in ideas, they will increase output, but that impact is going to diminish over time. It's going to diminish over time. So you can see this when you actually calculate the production function here. So basically you solve this model just as we did in class. The only difference is you have to carry through this 2/3 component. And what you find is that your production function looks just like this. The only thing that's different here is this 2/3 component, right? So now what happens if there's an increase in G, right? Let me actually, I'm going to switch over to my iPad. Let's actually draw the graph here. So what happens in this model where okay, there's our production function. Now let's say that there's, for instance, an increase in population, okay? that increases G, right? What happens in this model now? Before, we just saw the model kink like this. So it permanently increased output growth. But now, what do we see when we have a production function like this? Now, it's not going to permanently increase output growth. Output growth will go up. I didn't draw this very well. Output growth will go up for a little bit, but then it's going to go back to the same level that it did before. So this is what we mean by diminishing marginal returns to ideas. A new idea or an increase in population or spending more on research and development will stimulate growth in the short run, but it's not going to lead to higher growth in the long run. That's what you get in this model. And so, you know, I think actually a number of you did very well on this. This is a harder question, undoubtedly. This is, in some ways, I think this is probably the hardest question in terms of difficulty of the intuition, etc. But the fact of the matter is many of you did very well, and I think a lot of you were able to kind of figure out the math of this. And then even if you were not able to figure out the math, quite a few of you were able to kind of use your intuition to get generally what was going on. And I tried to reward that, right? Even if you kind of didn't quite understand the math, if you could kind of use your intuition and kind of think through what was going to happen, I was happy to give you a lot of credit for you know, just kind of having good intuition here. And so, you know, I think a lot of you did actually pretty well with this question, which I was happy to see. Finally, these last two parts of this question are really kind of right out of your notes. Compare and contrast the Romer model with the Solow model in terms of convergence. The Solow model predicts convergence because diminishing marginal returns is the key factor in the Solow model. The Romer model predicts divergence because countries that are rich have more ideas, and if you have more ideas, you'll always create more ideas. And so Romer is divergence, the Solow model, convergence. Finally, evaluate this following statement. In the Romer model, countries with a large population should grow slower because of diminishing marginal returns to labor. False. This would be true in the Solow model, but not in the Romer model. In the Romer model, if you have more people, you make more ideas. And if you make more ideas, you are richer, okay? So this is also another big contrast between the Romer model and the Solow model. And by the way, let me just say about all of these, the answers I'm giving, which are probably pretty short, a couple of sentences, were really all I expected from you. So for none of these was I really looking for a long answer. Typically when I would give an exam like this, I might look for a supporting graph, or I would ask for a supporting graph. I didn't really look for that this time because I realized that it's hard to take this kind of exam online. So, you know, really for the most part, I was looking just for a couple of answers. And so for those of you who had some difficulty with time management, I think that's one of the things that you can definitely improve on for the next exam, is to try to keep your answers succinct, right? And to focus on what's really important to say, as opposed to just kind of filibustering, which I definitely got the sense that sometimes a few of you who didn't know the answer were just trying to filibuster, right? We're just kind of trying to write some words down, hopefully thinking that I would give you credit for it, and typically I probably didn't. Okay, the last question. Growth accounting, the labor market. This was right out of your notes on Monday. I showed you exactly this graph. We showed how there's more people that have a college education, yet the wage for college-educated workers is also going up. This suggests that labor demand for college-educated workers is rising relative to labor demand for less skilled workers. Why? Well, we talked about three things. We talked about technology that is rewarding education-intensive workers. We talked about globalization that rewards education intensive workers. And we talk about the move to the service-based economy, which also requires more educationally intensive workers. So you needed to talk about two of those things, right? Two of those things that are driving up the labor demand for college educated workers, and can explain this graph. Part B, this is the bathtub model, right? And so the bathtub model, if you remember from your notes, you have your notes available, is just S divided by S plus F, where S is the separation rate, F is the finding rate. And so if you plug these in, you should get that the unemployment rate, the natural rate of unemployment is 0.04 or 4%. 4% of the labor force, it means that we should have 7.92 million people unemployed in the steady state. If today we have 10 million unemployed, that means that unemployment is about 2 million people too high, right? So short run unemployment would be 2 million people, right? The difference between actual unemployment and the natural rate of unemployment. Use the standard Cobb-Douglas production function, derive the growth accounting relationship. You know, once again, I'm kind of sorry I asked this question, because honestly, once I started grading it, I realized that most of you could not derive this because it means putting in multiple steps. And that was hard for some of you who only just type things. So basically, if you presented this equation or a realistic version of this equation, I gave you full credit for it. And so this is what we talked about from lecture in chapter 6, the growth accounting equation. This is right out of our notes, that the growth of output per labor, which is the GY minus GL, is equal to 1/3 the growth in the capital to labor ratio, which is the growth of K minus the growth of L, plus 2/3 the difference between the growth in labor force minus the growth in population. And then finally, you're left with the growth in A, right? And that growth in A is total factor productivity, right? And so we work through this and derive this in the notes. So I'll just kind of point you back to the notes if you don't remember from where this came from. And so the last question on the exam is, consider an increase in technology that increases the marginal product of labor. Where exactly will this show up? Well, many of you noted that, yeah, it will show up as total factor productivity growth. True, that's definitely true. It should show up as A. But what I also wanted you to note is that what happens if total factor productivity growth goes up? Well, that also incentivizes more capital, and it also incentivizes more people to work. And so when you have an increase in technology, it's really going to show up in all of these categories. And so what does this say about the accuracy of our empirical estimates of the sort of growth? There's a lot of error in these things, right? As we talked about, total factor productivity is a residual. It's really kind of capturing everything that we don't measure very well. And so there's a lot of ambiguity to these estimates, right? There's a lot of ambiguity. And so I think an answer that got complete credit here, I think noted basically two things. First off, that it's hard to separate growth in one of these categories from growth in the other, right? Like an increase in technology is likely to impact multiple ones of these categories. And then also to say that these kind of counting relationships have difficulties, right? They are imperfect, as is much of our economic data. So there you have it. There's the exam. If I could say just a couple of overall things about our performance as a class, a number of you actually did very, very well, right? When I talked about the average being a 62, I guess I didn't go and look at the exact standard deviation, but the standard deviation of this exam was large, right? I mean, I think there is a lot of you that did quite well on this exam. You know, a score, if you got up in the 80s, 85, that's a really good score, particularly for this first exam, which I think, you know, in general, you will do better on the second exam and you'll do better in the final as you kind of come to expect the level of rigor that this class asks of you, and you get a better feel for how you have to prepare for the exam. You get a better feel for the kind of questions I ask. I think most of you will do better over time. And so that's important. And I'll also say, for those of you who did not do as well in this first exam, as I think I've told a couple of you individually, in this class particularly, I weigh improvement and progress very heavily, right? So if you didn't do what you wanted to do on this exam, but you can do better on the second exam, you can do better on the final exam, that will be taken into account when I set your final grade, okay? And so, what you have to do in this class is you have to persevere, right? You just have to keep on working, right? That some of this, I know that a lot of this material is difficult, right? Particularly for some of us who may not have had as many economics classes, or maybe, our critical thinking skills aren't as well developed, or our analytical and abstract thinking skills aren't as well developed. This course can be a bit of a shock, right? And so you just kind of have to continue to grind it out. But know that I will reward grinders, right? So if you keep on working, if you keep on showing progress, right, that will definitely factor into your grade. Okay, all right. So does anybody have any questions that they want to ask as a group here? Yeah, Carson.
Yeah, so you said you're going to round it, but at the end of the class?
So I don't, you mean curve. I don't curve individual exams, so it just goes into my Excel spreadsheet of your grades as what your number is, right? And so in my grade sheet, I'm not putting an A or a B or a C on this, right? At the end of the class, there likely will be a curve, and I'm going to curve your entire score. But having said that, I know that all of us want to kind of we want to know what grade we got on this first exam, right? And so as a rough approximation, you can probably add roughly about 10 points to your score and then put it on a 90, 80, 70, 60 scale. So if you got a 65 on this exam, that's probably around a C, maybe a C plus, right? But it's probably around a C. But once again, don't put too much weight in that, right? That just kind of gives you an approximate idea of how well you did in the class. Or I'm sorry, how well you did on the exam. Okay, any other questions? All right. I apologize if I rushed through that. It seems like a long day. So I think I've been getting a little tired here at the end of class. But anyway, I'm happy to talk to any of you who want to talk on Zoom about this, or talk with me on email if you prefer to talk that way. So yeah, just send me an email and we can set up a time to meet. I'll have a little bit of time before class tomorrow morning. You might have a little bit of time before class or after class tomorrow morning. Same for the afternoon. I can also talk for a couple of minutes here after class this afternoon. So if anybody wants to stay around as we lock up, I can talk for a couple of minutes, okay? All right, if not, we'll see you tomorrow morning at 9, right? And remember, look for the email from me that has homework number 3 on it. Okay.
Hi, Todd.
Rose, before you go,
how much?
Rose, can I stop you? I'm going to end this session and then get back in it so I can stop recording. So just stay in here and I'll be back.